A very good evening to one and all. As we all know, we are here for the 52nd talk of the webinar series. On behalf of IEEE Malabar Subsection and IEEE Malabar Hub, I cordially invite everybody present. Topic for the day is Design and Development of Reconfigurable Antennas. We have Dr. Dinesh Yadav, Assistant Professor, EC Department, Manipal University, Jaipur, who is the current Secretary of IETE Rajasthan Centre. He did BE in Electronics and Communication Engineering and MTech in Digital Communication and completed PhD in UWB Reconfigurable and MIMO Antennas in the year 2018. I am proud to mention that Dr. Dinesh is a senior member of IEEE USA and also active member of IEEE Antenna and Propagation Society and former executive committee member of IEEE Rajasthan Subsection. He is a lifetime member of IETE and IE. He is known to be an author and co-author of 38 research papers, national and international conferences and journals. He is INAE Fellowship Awardee under the mentorship of Professor Shiban K. Kaur at Center for Applied Research in Electronics, Indian Institute of Technology, Delhi. He is also the recipient of SFRF 2014 and 2017 Fellowship by IIT Delhi. He is the recipient of Young Researcher Award 2020 by IEEE Rajasthan State Centre. Dr. Dinesh Yadav is the faculty advisor of IETE Student Forum and also IEEE APS and IEEE MTTS student branch chapters of Manipal University. Reconfigurable antennas are one of his major interests, so I'm sure that this session would enlighten all of us. So before starting the session, let me inform you that there will be a Q&A section in the end. I hope all will make the best out of the session. So over to you, dear sir.
Okay, thank you. Thank you so much, Amrita, for the introduction. And before starting this session, I would like to thank and congratulate IEEE Malabar Subsection for having such a long webinar series. And I wish it will continue and will go up to the century and more, so that the more the pupil can share his ideas and his their research, and they can collaborate. This is one of the main objectives. So I congratulate all the members of IEEE Malabar section and their associate partners for having this type of webinar and having me here. Thank you so much. So the topic which I have chosen for to share, this is my research topic, design and development of reconfigurable antenna. So before starting that, I just want to tell you that we belongs to Manipal University Jaipur. Apart from these technical societies which we are having the position and office bearer, so these only give us the strength as well as the only the motto to work for the students as well as the community, so that we can share our knowledge and we can share with the fellow students and the researchers also. So we are from the northern part of the India, Jaipur, Rajasthan. So it would known for its heritage. You all know the traditions. So there are some picks for you. And I'm from Manipal University, Jaipur. It is the youngest university, although it is having 10 years. But I can say it is youngest university which is having the zeal, enthusiasm, and passion for the devotion towards the research and innovation. So these are the few glimpses, and I invite all of you to come Manipal University and pay the visit here. And whenever you come Rajasthan or Jaipur, please do visit Manipal University Jaipur. Yeah. So these are some glimpses of. Now coming to the reconfigurable antenna. So first of all, the thing is, if you see this slide, the thing is coming to our mind, antenna. So what is antenna? Antenna is a device which radiate or receive electromagnetic waves. That means we can't think of any wireless communication without antennas. First of all, you can see in this, many of you familiar with the mobile antennas. This DTH antennas, direct to home applications, and surrounding you have seen many antennas which are mainly Yagi-Uda antennas and broadside antenna, helical arrays, and all such things. But those who are not from this field, this slide from those people, they can little bit aware about the antennas, what are the antennas and which type of antennas which we are having. So we will discuss later on the specific, some advanced type of antennas, array, that also used for the communication purpose, air to ground communication, satellite communication, airborne communication, many antennas, and small size antennas, planar antennas. So every antennas are having their own specific characterization as well as its radiation field, or you can say its range or the power handling capacity. On the basis of that, this characterization, if we need to go for the longer distance, we require high power radiators. And if we want to communicate for the shorter distance, for example, from mobile phone to BTS tower, you require low power communicator, and then the mobile phone battery can operate on to communicate through that antennas. So we are talking about the reconfigurability. First thing come in our mind as researcher every time ask that, what do you understand by the reconfigurability? The main focus on reconfigurable antenna is without changing the antenna characteristics, antenna physical dimension. There are not major changes in antenna characteristics and their designing pattern. We can switch its resonant frequency or the polarization or maybe its radiation pattern through right hand circular polarization to left hand circular polarization. If we move from one radiation property to another radiation property, then it is called the reconfigurable. That means we are maybe switches we are using some mechanism over there. So these things have been included in reconfigurability. That means the main focus is without changing the physical structure of antenna which we are designing for the particular application, we are switching to the another resonant frequency or the phase or the polarization. So this is the basic principle behind that, and it will giving the versatility to the reconfigurable antenna, so that the bandwidth when which we are using one antenna for particular application, we can switch to the another application. This is the whole idea. So the reconfigurability, changing the shape and the changing the shape of the antenna. So these are mechanically reconfigurable antenna. If we have some motor and type of thing, we are rotating around the feed line, then we are getting the mechanically reconfigurable antennas over there. Then material, if we are having the different material, if we apply the electric field and their dielectric constant will change, then again these are called the material reconfigurable antenna. And then switches, we will discuss more about the switches and the reconfigurability which I have produced with my research during my PhD, as well as continues with some of the students. So these are the glimpses of the reconfigurable antenna. You can see the first one is, if there is a radius of this circular loop type of antenna where we are having the surface, if we are able to move its surface, we can increase or decrease its outer dimension, then it is called mechanically tunable antenna. And you can see also there is a materials. I told you, I discussed this thing, that if there is a applied electric field, then the dielectric property will changing. So this also materially reconfigurable antennas. And also the switches, this is very important and crucial part. And lower to that, you can see there are different the antennas which are mounted on a single plane. If you can see, there is a bulb type of antenna, if it is connecting with the coaxial connector, which is the supply. So what happens if we feed the energy from here, it will provide you fixed radiation. Whereas if this antenna, all antennas are fixed at a rotating surface. So one time this antenna is connecting with the feed, second time this triangular shape, and then a small type of circular antenna and triangular shape antennas. So these are the reconfigurability had been produced by mechanically moving the antenna surface. But yes, this thing is very important. What is the impact of these antenna whenever this one is radiating? What is the impact of this antenna? So these antenna become parasitic element for this type of configuration. So this is also, so this has been reported in Dublin. So these things you can see if how we rotation can control the reconfigurability if we get the desired radiation. So this is the another feature, and this is the liquid crystal. If we apply the electric field across it, it will change its dielectric property. So this is also the one of the reconfigurability you can produce by this. Now we are talking about the switches. The switches are the it is continuous or discontinuous. That means they are continuously switching the resonance from one point to another point. For that purpose, we require the varactor diode. If we are having only discrete position, one position of the switches is switch is on and off. If we are utilizing that effect on our structure, then it is known as discrete switches. And discrete switches having the MEMS and pin diodes. All switches are having their advantage and disadvantage, and their speed as well as their functionality. So as I told you, we can produce these type of reconfigurability using that. That means frequency reconfigurable antenna, maybe polarization. We can switch from right hand circular polarization to the left hand circular polarization, or circular polarization to the linear polarization is required. Then the pattern reconfigurable antenna, many of the application require the specific beam to be direct towards the particular satellite or particular object. If we can switch this beam, that can also come under the reconfigurability if we are having the background support for that switching also. So this pattern reconfigurability also used for the versatile of application. So yes, design, again the antenna designing is crucial part, but it is one step ahead. How to design the reconfigurable antenna? You require the very sophisticated lab for that. For that you can switch, you can mount the switch on the surface, or you can mount the MEMS switches over the substrate. So for that you require the very small size diodes, so that it would not affect the radiation characteristic. Their resistances should be very small. So MA4SVS 402 is the one of the diode I have used for my research in which is known as pin diode, and many more diodes and many switches are available with their specific characteristic. So these are the setup which I am telling you. It is the source for that is this is the CARE lab from IIT Delhi, and I have done the fabrication and measurement process under the mentorship of Professor Shibin Kaul and Dr. Mahesh Abhigankar during my fellowships, which I mentioned in my introduction. So yes, sophisticated lab is not only limited to the fabrication process, it also required the chamber measurements for the specific type of antennas which are reconfigurable, because the very crucial thing in the reconfigurable antenna is the how we are supplying or feeding the energy to the antenna, and then the energy which we are feeding to the diodes, which we are additionally using that to particular antenna, which is also very crucial. Because if you are using the wires and the diodes, inductors, capacitors with your structure, then it become more bulky. And if we check the radiation characteristics, sometimes these components interfere with the other bands. So what happens, the resonance may shift from one operating point to another operating point, which you are expecting during your simulation, but your measurement you are not getting the appropriate and right results. So these are the challenges which we have to look after during our design. And again, we need to focus on how to minimize these effects. Okay, so simple metallic switch, if we talk about, if you can see in this diagram, it is already it is clear that there is a two metallic substrate. The yellow one has been shown here. There are two copper substrates, and there is a one element which is known as metallic strip. I can say it is a diode, but you can just understand there is a on and off state over there. That means this metallic strip is present over there, or metallic strip is not available over there. If I compare with the diode, I can say the diode is on in this stage and diode is off at another stage. So how devices behave in these two configurations? For example, if we use one diode, there are only two cases, on and off cases. If I use two diodes, there are four cases. Both diodes are on, both diodes are off, first on, second off, and vice versa. So these are the cases you have to just go through with these diode if we are having a specific structure, and when which we are using the diode. So again, how when these are antennas are using at the on and off state, you need to analyze how this switching has been taken place. And what are the factors are responsible? Here in this diagram, you can see if diode is on, the red one is there, the return loss, and if you see if the diode is off, it is shift to below to 4.5. The resonance is shift to that. So what are the factors? How the surface current is behaving, how the diode structure is behaving after switching on and off. So this is the one of the point for the analysis in the reconfigurable antenna. So this is very initial paper which I have studied, and I was impressed with this paper. In this paper, it published in IEEE letters. In this paper, you can see the structure is very simple. Here, what the concept is, if we use a diode across a structure, so you can see here, the diode is using here, and the diode, this one is the diode, and there is a metallic strip, and there is again the capacitor in between. So if you analyze this one, so you can see if the capacitor is connected in between these 2 points. So this is the metallic strip, and this one is capacitor. So what is the motivation of that? If you can see, if there is a capacitor is connected in between 2 metallic strip, it will provide it will pass the AC, but it block DC. So what are these 2 things which is really motivate us use capacitor and diodes in all together? So if we use the AC component, if what is AC? If all antennas are working on a time varying field, and if the information is all about the time varying field, we are applying a sinusoidal signal, co-sinusoidal signal to a antenna which is frequency modulated and amplitude modulated. These are such a high frequency signal which the low frequency have been superimposed over here. So these are the time varying signal. If you see, there is a time varying surface current is there is shortest path for this. That means there is no open circuit for the time varying signal, but there is a short circuit for the DC because it is blocking DC. Similarly, if you go to the diode, what happens? Diode will switch on and off on the basis of the applied DC voltage. Okay, so if the DC voltage is more than barrier voltage of the diode, it will switch on and it will switch off. So here you can see their surface current, this path is always connected. There is always connected path, and it is disconnected from here, black one here. So diode is playing the role. What happens if we connect the diode in between these 2 structure? That means diode start from here and up to this point. What are the problem? You can check, there is a surface current shorten here, and it will also flow from here to here, this point also connected here. That means you need to understand that whenever we are using the diode between the 2 metallic strip, they should be physically disconnected. They should not have the connection, so that the biasing has been taken place, because we have to bias positive, forward bias, and negative to here. So what we are doing, we are connecting positive through inductor and negative over here. So yes, biasing will work, but if we are not using the capacitor, what is the problem? If we are not using the capacitor in a structure, what happens? These are shorted. That means that the biasing will not work. So diode, if you use the metallic strip, it is present or available or not available, you will get the characteristic, but the same time you are not able to get the characteristic of the switching. The practically it is not possible to fix a diode over here. So these are the main thing which need to address. So in this paper, there is a ultra wideband characteristic from 3 gigahertz to 10.6 gigahertz has been achieved when the diodes are in off state, and there is a band notch characteristic at this frequency band at the on state have been required. So the main idea is ultra wideband antenna are the antenna which are having 3.1 to 10.6 gigahertz. But what happens at the entire bandwidth, there is a limitation by the FCC, Federal Communication Commission, in 2002, that you can't radiate more than minus 41 dBm power, because the same power would be assumed as the noise level for the narrowband system. So the ultrawide system will not affect the performance of the narrowband system, but vice versa is not true. If we are using the ultra wideband range for the narrow band frequency range, for example 5.2 gigahertz or 3.3 WiMAX band or 5.2 WLAN band, we are using the ultra wideband antenna, then what happens, the narrow band system may affect the performance of the ultra wideband antenna. So what we are using, we are providing a band notch for that purpose, and this band notch is we are producing the filter through the structure. That means this antenna is not radiating or receiving such amount of such band of frequency. This is the whole idea. So whenever in close proximity, if there is a narrow band system is available, so you can't use that particular frequency for the ultra wideband communication. But if in the close proximity and close surrounding, if there is no narrow band system is available, you can use entire band. You can transmit the information from one point to another point, so the short distance with the high data rate and a large distance with the low data rate. But again, it depending on the characteristic which you are using for that purpose, it should be not using the same close proximity. So these are the idea that here they have used the switch for the band notch and without band notch. So the one characteristic is utilizing entire band and one characteristic is not utilizing entire band. Again, you can see in this literature, you can see there are 4 capacitors are using here. So number 1, 2, 3 and 4. These 4 capacitors are placed over the position which have been shown here. That means for the diode, it is giving the biasing because you are placing diode here and here. So this upper part is not connected with the lower part. Yes, it is true, because there is a capacitor. And if you can see, this part is not connected with the lower part. Yes, it is not connected. You can fix the diode over there in between these two if you are getting the desired characteristic. Because you have introduced capacitor, it is blocking the DC. But for DC, it is not, it is open. But for AC, it is connected. If you are talking about the antenna structure, yes, this is the structure. Yes, this one is the structure where all are connected. Or here you are using the switches. When it is on, there would be connection here, and it would be on, their connection would be here. So you can see the configuration over here. So this is the how the design have been processed. So in this case, you can analyze that this is the case. I told you the capacitor is here, capacitor is here, capacitor is here, and one capacitor is here. It has not been shown in this diagram because for the sinusoidal current or the time varying current is coming, for that it is shorted. There is no open circuit for that, because we are talking about the antenna. Antenna is behaving because capacitor is here, so it allows the surface current to flow. It allows surface current to flow here also and here also. But if we are talking about the switches, switches would be biased through the inductor. Okay, an inductor allows pass DC and block AC. So reverse. So the AC is not coming out from the structure. That means you can save your efficiency of the antenna. So in this case, the biasing is there. So these are the case where the what diodes is on. In this case, what diode is off. This is the case. First one is on. This one is second one is on. So you can get the desired characteristic, and these are the results you can see over here. Yes, obviously it is not the diode you can use anywhere. You have to check what is the structure. It is in terms of lambda by 2 and lambda by 4 for the resonant frequency. Switches you are creating, you are making the switches at particular position will give you the surface current, and that surface current will give you there is some structure which is blocking that particular frequency band, and that particular frequency band is blocking, it will produce the band notch. This is the first case where the D1 and D2 is on, you will get this type of characteristics, and where the other characteristic is there, you will get this type of band notch here. So these are the thing you can understand. If it is not possible that if you are having 2 diodes, 4 states are there, and all 4 states would give you the appropriate result, because they have to tune for certain frequency and wavelength, or the polarization, or the maybe it's switching of its polarization characteristic, or the beam. But the same time, if we are talking about, these are the frequency reconfigurable antennas. These are not we are not talking about here the polarization and this thing. We have to go for the different type of switching characteristic over there. If we want to rotate the surface current, we have to fix the switches at the edges of the antenna. If we have to rotate clockwise and anti-clockwise, accordingly we have to go through for that. Now I am quickly coming to my own findings for the reconfigurable antennas with the diode switches. So there are the circular monopole antenna which I have published, and in joint collaboration with IIT Delhi and research lab of microwave lab Rajasthan University and Manipal University Jaipur. So in this paper you can see there is a structure, very simple structure. If we start with the with a monopole antenna which has some certain frequency band which radiating 3.1 to 10.6 gigahertz. Now what we are doing, we have to introduce the reconfigurability. For that, what I have done, I increased the surface current path, and I cut down these two slits over there. So what happens, the surface current path have been reduced. For that particular band I am not getting the entire ultra wideband frequency. So again I have introduced this, I cut this slot. So what happens, again the surface current, if I measure from, in this case it is 2 pi r. So this is the path. Now this path would be compensated by this path only, like this. So I will get the same radiation with that, and I use the switches in particular position, this one, this position, and this position. If I analyze entire structure, I can see there is a T-shaped slot become here. This one, this T-shaped slot have introduced, and I've measured all the dimension of that. Then it become a absorber for the particular frequency band. So this is the whole idea, and this how we can physically design that. A microstrip patch antenna is over there. So these diodes have been fixed over here. It is a P type or N type. This is P side, this is N side. This is again, we have given the P sides for this diode is also P side. This one is N side. Above diode, it is P side or N side. So I have to connect positive here, okay, and the negative to the this one through this inductor, negative, this one through this negative, and this one negative. If I bias these diodes, and what I am doing at the same time, if I am applying 0.7 volt, which is the barrier voltage for the diode MA4 SPS402, I have used. In this case, I can give you, and you can also analyze through the data sheet, that if the barrier voltage is more than, it is switch on. So I can on all diodes together. I can on one diode at a time and another diode at a time. I can switch on and off. So it is depending on the biasing. Okay. So if this biasing has been taken place, we can see that the characteristic would be, but we need to analyze what is the behavior at that position, how these diodes have been taking place. So these are the mathematical equations, how we have started with the monopole and how this monopole is equivalent to the cylindrical monopole. These are the analysis I have done for the basic antenna designing for a monopole, and all the calculation I have been done so that I can get the lower cutoff frequency around 3 and the ultra wideband for this application. So ultra wideband I can I have achieved, you can see from here, this point, excuse me. So I can show you here, you can see from 3 to this one, I can show you it is more than ultra wideband. But in this antenna case 1 and 2, these are the method how to optimize and how we can get the entire ultra wideband. These are the basic structure which we need to make. So ultra wideband I get from here. This is the second one. I use the lambda by 4 transformer over here, but certainly when I go to reconfigurability, I need to check the antenna should be switched from one operating point to another operating point. So here we use the band notch characteristic. In band notch characteristic, what we have done, here you can see the 3 diodes which use, and at a time, if all diodes are on, this T-shaped, this T-shaped structure will tune for the blocking for this band, entire band, 5 to 6 band, which is WLAN and WiMAX band. So when these diodes are switched on, I can get this notch band, and these diodes are off. In this case, the ultra wideband radiation from here to here, this band also. Okay, and how this structure is looking like, if the antenna is on, and off. So in this case, there is on, there is a off state. So I use the metallic strip to show over here, and it is not only limited to the excuse me, it is not only limited to the antenna characteristic, but it is also limited, also extended up to the its circuit behavior, because in simulation we use the inductor, capacitor, diodes, but physically there is many more impacts of these components over there. So we also did the circuit analysis over there. We consider these antenna as a port, discrete port, and as a 4x4 matrix we have introduced for that. In the one port is antenna input, which is the sinusoidal one, RF input, and these three ports, discrete port, would be considered for the diode location. And we have did the equivalent circuit analysis over there. If these antennas were there and the diodes are there with the inductors with their feed energy 0.75 volt, then how this structure would be behaving, so that we can find out. So this has been done, all the simulation has been done in CST, but this simulation circuit analysis has been done in ADS software. So ADS, we have taken this all transformation of these results, and we physically we were going to connect the diodes and inductors. So we analyze this behavior, and this behavior will tell you if you are going to make these antenna, these are the shift in the frequency response has been encountered, and you have to taken care of this, because we have given the inductor 30 nanohenry, which we are using for the fabrication purpose, same diode specific with the specification. So these are the results. There is a little bit shift in the frequency of the resonance of the entire band, you can see, and the surface current is also telling, or at 5.5 gigahertz the entire T-shape structure is having the maximum surface current over here. So it is indicating that it will block the frequency, because this current is not coming out from the in converting into the radiation at particular band. But other band, you can see this is equally distributed. So these are the case. You can see there is a red one, and the blue one is the analysis for the two simulator softwares with the circuit analysis as well, and the measurement has been taken place. There is a good matching has been found in this antenna, so it has published in good journal. So now I just skipping this part, the radiation pattern and all performance of the antenna at different frequency on and off state, because we are not really changing its resonance radiation pattern, because if if we are changing the frequency from one operating point to the another, the pattern of that particular frequency will also switch from that particular band to another particular band. So that analysis also is needed in the future work of this which have been. Now we are last work which we have done with the 3 diodes. Okay, this is the initial work of my PhD, but what is the complexity over there? We are found that only we are using 3 antennas, 3 inductors, there are wires and lots of things. Why we can't do this from the one diode only? So we again rework on that, and we are coming out with the solution, and we publish in a good conference of international level. So this antenna will give you the resonance shifting from one entire UWB band to the band notch. But here we are using only one diode. Okay, so you can see here there is a one diode only, and these are the biasing pad to bias the diodes. Okay, so if we apply, there is a diode. If this is the P side, if I can say this is the P side, this is N side, and this biasing pad is connected with the positive terminal of the battery, and there is a negative battery is also connected here. So what we will get the forward biasing for this. It is connected and disconnected. So we analyze the entire structure like the previously we have done, and we are coming to the conclusion that if there is a diode is connected and disconnected, we can do with the same single diode, same application. But here we have analysis, we have started with a circular antenna, and we increase the radius of the antenna and cutting down to the hexagonal shape. Now hexagonal shape has been cut down into the 2 part, not in symmetric, non-symmetric. One is aligned to the feed line, one is remaining part. So if we connect with the near to the feed line, what we found that the notch characteristic has been produced. So this is the main idea, and we just what we have done, we are started with the 3 diode coming to the 1 diode for the 1 frequency notch. Okay, so these are the radiation characteristic of this antenna and the surface current and gain. Although the gain of the ultra wideband antenna is nearby 4 dB, but which is reasonably good. But yes, if we go for the narrow band, we will get the good gains for the antennas nearby 7 to 8. So gain enhancement technique we also incorporate and include here also, but again it's scope to the future. So the frequency reconfigurable monopole antenna with switchable band characteristic from UWT to band notch UWP for the dual band resonator. There is another work we did. In this work, what we have done, first we start with the 1 notch characteristic. Now there are different bands, different narrow bands. 3.3 gigahertz, maybe 5.2, maybe 8.2 gigahertz. These are the bands which is available interfering with the ultra wideband system, and uh, they they may uh, they may affect the performance of the ultra wideband antenna. But reverse is not true, I told you, because there is a limitation for the power spectral density. It has been radiating not more than 41 dBm. So this is only the ultra wideband antenna. If it is radiating more than that, it is not coming under the category. It is unlicensed band. So this work has been done in this ultra wideband antenna has been first of all analyzed, and through mathematical calculation, the lower cutoff frequency has been tuned around around 3 gigahertz and going up to the 10 gigahertz. So the blue one is the appropriate antenna, the third one, which is required for the particular band to start with. Okay, now coming to that, we are having the antenna number 3, 4 and 5, 4, 5 and 6. Then in this case, what we have done, first of all, we cut a ring at the center of this antenna. So by cutting the ring, we lost the surface current distribution among these entire surface, and this ring will reduce the surface current distribution. Distribution would be more on the ring, so it will produce less radiation in the center band of this frequency. In this case, if we cut the slots, so what happens, we also introduce a rectangular uh, patch over there, and which is disconnected at the lower end and connected at the upper end, and we introduce a horizontal 2 slots over there, and now we have the possibility to fit the 3 diodes over there. But again, these are the 2 slots which we have kept for the capacitor. So we did lots of mathematical calculation before going to this type of structure, and we just find out these positions where we can fix the diode. So there is D1, now here is D1, this is D2, and this is D3. And the capacitor we put here C1 and C2. So for capacitor, this ring is connected. Sorry, for the time varying current, this ring is connected. But for DC, yes, the upper portion is disconnected with the lower portion, and biasing can work for this diode. So we are having the multiple switches over there. So as I told you, you can see here in this structure, this D2, D1 diode and D3 diode are placed here, and these are biasing paired through inductor L1, inductor L2, L4, and this one is L3. Okay, so there are four possibility, four inductors are there. So in this case, you can see if the diode is biased, okay, so there are the 3 diodes. There are the lots of possibility, 2 raised to power 3. But in this case, we analyze mathematically. Now, if all structures are connected, this structure, now this would work, and this would work symmetric structure. This would work as a blocking structure, blocking slot for the particular frequency band. So we are utilizing that effect, and mathematically we have calculated the dimensions of the antenna, and we found out, and this is the fabricated one. The capacitor have been placed here, C1 and C2. The diode is D1, D2 and D3 is here, and these are the biasing pad. So here you can see the positive is written here. Here the negative is there, the negative positive terminal is there, positive terminal is there. So these diodes have been here will be forward bias, and at a time we can on and off the all diodes together also, and we can connect. So in this diode characteristic and the if the switching of the diode, we can see if there is all diodes are on. In this case, the entire ultraviolet band we can find out from 3.1 to 10.6 gigahertz. It is more than 3, but in the measurement you can see that it is more than 3 gigahertz is around here. And if you switch on, there are two diodes you can switch on, D1 and D3. So this one is the structure, 3 diodes are on, and this one is already connected for the sinusoidal. Always it is connected. These two terminals would be connected here. And this is the case where this diode and this diode is on, and this is off. Okay, so I can say D1 and D3 is on and D2 is off. Using that, we can get the band notch characteristic. Also, we have introduced one more characteristic over there. If we connect this two diodes, or this center diode and this diode, if it is at on state, what happens? The middle band will be not going to be radiated in this antenna, so it become a narrow band radiator for this band and this band. But because we have used the capacitor over there, there is a lots of fluctuation we have encountered during the measurement part. So these are the things we have experienced during the fabrication and measurement. So the simulation part, it is going very smooth. If there is no, if we are coming to the fabrication part, there is a lots of fluctuation is encountered due to there is a presence of the capacitor over there. So again, we have to rethink and analyze. If we are using the capacitor, its values are very high, then what happens? It should be in picofarad. So like this, we can minimize the effect of the capacitive behavior which is encountering in resonant frequency. So this thing again, yes, we told that some surface current at particular frequency will be blocking the antenna performance at 5.3 gigahertz band, and this radiation of the antenna from this ultra wideband radiating band to the band notch characteristic have been shown here. So this have been published in APMC, Asia Pacific Microwave Conference, and these are the different modes of the diodes have been shown. Now there is one interesting work which have been assigned by Professor Kaul and Dr. Mahesh Abhingaonkar, that why not we design such an antenna which can switch the resonance. That means it can reverse the behavior of the antenna. For example, if it is radiating and it is creating the band notch, the reverse characteristic we will get. It block all the initial bands which is radiating earlier, and it become band notch for the reverse condition. For example, antenna is radiating 3.1 to 10.6 gigahertz, and the band notch at the 5.2 gigahertz, central frequency 5.2 gigahertz for the WiMAX band. So can we design such antenna which can radiate only 5.2 gigahertz and it block entire 3.1 to 10.6 gigahertz? That means two possibilities. One is band notch and one is reverse of that. That means it only radiate for the WiMAX band. So this is again the interesting work, and we have worked for more than 1 year on that. And we have designed an antenna. First of all, yes, the ultra wideband antenna need to be designed and evaluate through the mathematical calculation. And this antenna have been designed, and backside we have the parasitic effect, and through parasitic effect we introduce the band notch. And then we are having the defective ground effect. You utilize the defective ground effect and use the 5 diodes. It is although it is complex structure, 5 diodes at a time, but again we need to block the entire 3.1 to 5.2 and after that also. So for that we have to work for the different frequency bands. So we have segregated in the first band and the second band, and then we start to just blocking their radiation. So finally we got success in this work, and we have found that the switching of band is also achieved, and it is published in Progressive Electromagnetic Research Journal. So PIR, sorry. So this work also iteration is required before the diode, placing the diode, how band notch can be fixed, how the position of the band notch has been fixed, and then this is the structure. You can see here there is a diode number 1, 2, this is 3, 4, 5 diodes have been used. This is the zoomed view, you can see. And this is the inductor for the biasing over here, 1, 2, 3, 4. So it is very complex in functionality, although we have lose some antenna efficiency, but the radiation is very good at that frequency band which we required. So you can see the result, although result is supported by the all the background of its circuit analysis which we have done for the 5 diodes on and off discrete component. ADS simulation has been done, and after that we are coming with this surface current distribution, and we found that this central frequency, in this case, this is the blocking band and this is allowing band, this is radiating band. Okay, now you can see here this frequency is only the radiating frequency, this one. Okay, so this switching is required, and this entire band is blocked, this entire band is blocked. So this is the work which we have done with the collaboration of IIT Delhi Care Lab, and this work got the lots of appreciation. So this type of work which was not published before that. So this work I want to share with all of you, that if we are using the diodes in such a way, we need to go with the mathematical analysis of the band, how the band is behaving. It is not an hit and trial method. You are getting something out of that. It will work for you, because you have to answer lots of query of your reviewers as well as your professors. So yes, these are the things which we are able to publish in good journal. So these are the radiation characteristic of antenna. Again, the efficiency and gain I can tell you around 80% we get for this antenna. Okay, so the gain is nearby 5 dBA for the maximum gain, you can say. Now again, we are switching at why not we use the dual band notch antenna, and we can switch whenever required. We can switch from one operating point to another operating point. So first of all, what we did, I'm coming short of time. So we started with the ultra wideband antenna, which is the initial requirement for the communication of the band. Now what we have, we use the parasitic U-shape and dumbbell shaped parasitic resonator. It is also, this work also published in the Q1 journal, and here we use the dumbbell shape, and so we are blocking at a time 2 bands, because these 2 structures are tuned for the particular frequency band which is blocking the radiation. So okay, so first of all, these 2 bands have been produced here. Here you can see with the first structure is used, we can see here there is a notch band, and the second structure is there is a notch band. So we analyzed all the measurement part, why it is happening. Okay, so in the basic structure, if we combine all these together, we can find out this. That means one is 5.2, one is at 8.2. We can take at 3.1 also. But for that, we have to work a little bit on the higher, the lower frequency, which is 3.3 WiMAX band. So we can get the 3 band notch, but switching and this thing will make the circuit complex. So yes, the work is still continue. We will work on that. So these are the things, and these are fabricated and measured results. Now what our next expectation and what are our main objective to design this antenna? This is the basic antenna. Now one time if I can get this notch band, and second time I can get this notch band. Okay, so these are the characteristics. This only has been done with the reconfigurability. So we use the reconfigurable antenna for that. These analysis I am skipping. So rather than having 2 structure, we combine the effect of these 2 structure in a single structure, H shape, and we have introduced slot at these 2 positions to fit the diodes. It is the back side of that. You can say the front is this one, and this is the back view. So the position of these, and we are combined the effect of these 2 parasitic element in a single element. So we are making these 2 elements in a single element, this H shape. But H shape is again divided into 2 parts. Number 1 is this one, lower one, and second one is when it is connected, entire. So there is a disconnected with parasitic elements and this connected with the H shape parasitic element. So this one is the first case, and you can say this one is second case. So we need to analyze the effect of these parasitic and this you can say U shape structure on the resonance of that. So again, yes, we get the 5.2 and 8.2 bands. Now we got that type of radiation characteristic we required, and which one will give you at a time one notch. Okay, so if you can see in this characteristic, what happens when there is diode is on in this state, if the both diode is on H shape parasitic element, I can get this one 5.2. If these both diode is off, I will get this higher frequency, because this structure is having the smaller dimension compared to H shape. So it is tuned for the higher frequency, okay, in terms of lambda by 2. So it tuned for the, and I get the band notch at the 8.2 gigahertz around. So I can see it is known as the as required switching as required. So these are the structure which you can see over here, and this structure has been supported by the mathematical equation as well as the circuit analysis part, which is very important and crucial for the reconfigurable antennas. If we are using tunable or reconfigurable antenna with these elements, which we have done, and we found the effect of the individual elements, inductor, capacitor over there before fabrication, and we got the good matching after the fabrication of these results. And these are the characteristic. You can see the gain is reducing at this notch band. This is the first case on and second case is off. So you can find out the antenna characteristic, how it is switching, and at desire you can switch from the one band to another. So if I conclude my entire talk, that the reconfigurable antennas which we have shown here, which are frequency reconfigurable, we can go to first step forward to towards the reconfigurability and linear and circular. So I have not included my work after my PhD, but in that case we have introduced one antenna which is converting its resonance from linear to circular polarization without changing the resonating band. That means it is only the polarization switching. Okay, so for example, it is radiating from 3.1 to 10.6. We are not talking, I have not done that work for the ultra wideband, I have done for the narrow band. So it is 2 to 5 gigahertz band if it is radiating. So in this case, 2 to 5 case, if diode is on and off, the same radiation would be there, but the polarization is at the time it is linearly polarized antenna. For linear polarized antenna, the axial ratio bandwidth is more than 3, but axial ratio bandwidth is 3 is coming when diode is on. So these type of antennas we have reported and published in IETE map micro antenna journals. Recent work we are doing on the frequency selective surfaces, EBG structure, phase gradient meta surfaces, antennas for the biomedical application. These are the latest work which we are doing, and there is a lots of scope. The work which I have done, it required we can go for the MIMO configuration, because nowadays the data rate is the issue, and the MIMO is the for 5G communication. It is the required. We can go for the antenna. We have collaborated, Dr. Millen and we all are doing on the how a MIMO of array can be used for the wireless communication with one scholar. So this is all about. I would like to especially want to mention my BTech students, because there is no motivation for these students to doing the research, because PhD student anyhow he has to publish good quality papers, but the BTech students are supporting your research. So I just want to especially acknowledge these students. Just these are also the office bearer of my student chapter IEEE MTTS APS, which is very active in Rajasthan. We have also done 16 activities single-handedly with the student chapter last year, and we have organized many webinars, workshops, industry conclaves as well. So these are the students from my MTT group, and these are the students from my APS group, which are actively working, and every student published more than 3 and 4 research papers during his BTech only. So this is the main motivating factor for me to work hard with if the students of the UG level are joining the group and coming forward to publish the research paper, and yes, they are also getting the benefit out of that. One of the student is in our group right now in Germany, one is in Arizona State University. They are doing masters, and some senior student doing PhD. So again, the whole idea is to connect the people. Think big. My professor Shibin Kaul always say that think big, you will get big. It will return back. If you are downing yourself, it will not work for you and others, those who are associated with you, because your mindset is very narrower. So what you can do to your fellow students and your colleagues. So this we are thinking big. So I especially would like to thank each and every one of Malabar section who has associated in this webinar series. This is the tremendous and absolutely very good work you people are doing. Otherwise, we are not able to connect, we are not able to share our ideas, and in future we are able to just not only the share our ideas, we can collaborate also. These are the opportunities, and again, this opportunity for the student as well. From here, they can connect there, and they can exchange if there is some internship or the research possibility for the both the students of our region and that region also. So this is all about. Thank you so much for having me. These are my contact details. If you have any uh, required any collaboration, or you want anything which help us also, you are most welcome. Please contact on my email ID. Thank you so much for having me. If you have any query, I'm very happy. I will be happy to answer. Thank you, sir.
Firstly, for inviting me and then reading out my biodata. On this occasion,
Thank you so much, sir. I'm sure that this session was helpful and inspirational to all of them.
it is very interesting and very elaborate, Mr. Dinesh Yadav.
Thank you, sir.
And I see, like you, your university, you are also very young and doing a great job there.
Thank you so much, sir.
Because antennas nowadays, I must say, very few students select that as their favorite subject.
Yes.
Because most of the engineering branches are converging into computers now.
Yes.
It's good. Your lecture is very interesting, and I wish to have a video of this and work on further with you. I am a manufacturer of micro anechoic chambers for Bharat Electronics Limited for the past 25 years.
Great, sir. Great. Great.
I think I would interact with you. I take your details.
Sure, sir. Sure.
Thank you.
I would be happy, more than happy, sir.
Yeah. We have established a few test facilities in different places in India.
Oh, great.
Hyderabad, Chennai, Bangalore, Pune.
Yes.
And I am a consultant for Musgon Dock Limited for the antenna products, antenna micro observing material onboard Navi,
Yeah.
MDL.
Great, sir.
I would be happy to take your help in preparing some designs and all that in this.
Sure, sir. Sure. It would be.
Chambers, it's my brainchild for the past 25 years.
Sure.
Go ahead.
Sure.
You please give me your details. I will take from my friend
Sabik sir.
Sabik, I will take contacts from. That's it. Very good.
Thank you.
Thank you.
Feedback form have been shared in the chat box, so all the participants, please do fill the form.
Sir, I need to make you host for that. Sir, I will make you host and sir, I am reading the host.
Do we have any questions?
I think there is no more questions. I think.
Okay, sir. I would like to thank all the participants for joining in this event. Thank you, one and all.
Thank you. Thank you so
So
much.
Dinesh sir, on behalf
Thank
of
you.
IEEE Malabar Subsection, a very big thanks
Thank you.
for handling this session. Okay, it was a wonderful session, and hope we'll have in future also
Thank you so much. Thank you.
another
Sir.
topic. Okay.
We will. I will be more than happy to share whatever our findings and latest finding as well.
Yeah.
with
That's
the-
right. That's right. People
Thank
are
you.
there working in this area so that it will be useful for them.
Sure, sir.
People
Sure.
who are doing research in this area might be stuck up with some points
Yes.
where they can clear from you, like
Sure, sir.
if they are working in antenna.
Sure, sir. Sure.
Okay. Bye.
Bye. Okay. Thank you. Thank you so
Thank
much.
you. Thank you, Regular sir. I'll give you the details later.
Could we request to all of you for a group photograph if they can switch on their cameras? This would be great for memory.
Great. That's good. That's good.
Sir, my profile picture is better.
Original is original always.
Original, yeah, okay.
Thank you. Thank you so much. Thank you so much.
Dinesh's wish. Okay.
Thank you so much, sir.
Okay. Thank you very much, all of you.
Bye.
Bye.
Thank you very much.